we're going to explore 3 different ways of theorizing identity: binary theory, spectrum theory, and configuration theory. At this point, we should be pretty familiar with binary theory. This theory assumes that there are 2, and only 2, possible categories for a given dimension of identity. Some of the binaries we've studied are those of sex, gender, and sexual orientation. The binary model conceives of each identity category as rigid, with clear boundaries that a person must fit within in order to be counted as, say, really a man or really a woman. Much of our world is built up around these binaries. Even when we want to, it can be hard to escape binary thinking. But there are big flaws with the binary model, most especially that it leaves a lot out, and it doesn't allow space for many people's identities. In contrast, we have spectrum theory. Spectrum theory recognizes that dimensions of identity exist on a continuum, or a spectrum, and cannot always be carved out into distinct categories. For each of the binaries we studied, we can conceive of them as a spectrum. A person's identity can fall anywhere along each continuum. The continuums needn't be linked the way that the binary model presumes sex and gender are. Strengths of the spectrum model include that it gives recognition to identities that are not captured by the binary model. It doesn't enforce rigid boundaries of what counts as really being a member of a category as the binary model does. There's a lot more latitude or flexibility and not as much gatekeeping. It even allows for fluidity and movement along the spectrums. People aren't locked into a particular category, but instead might find themselves at different points on the spectrum at different times in their life. We gain a lot when we move from binary theories to spectrum theories. However, there are also some weaknesses to this model as well. First, notice that it positions the binary categories at either end of the spectrum, which is still implicitly drawing on that binary thinking. It quite literally constructs the spectrum around the binary categories. Second, it positions identities outside the binaries as somehow between or in the middle of the binary categories. But that just reinforces thinking of those binary categories as the real or pure categories, and the rest as some kind of muddled other. In practice, it functions to just add an other, third category to the binary. We even see this on lots of forms that require people to select their gender from the options man, woman, other. Next, by positioning the binary categories at either end of the spectrum, spectrum theory continues to assume that the binary categories are somehow opposite or far away from each other. But the only reason to think those identities are opposites is because we're so used to binary thinking. If we look at sexual orientation, we could just as easily view being gay and straight as very similar, because they both describe being sexually or romantically attracted to only one gender or sex, in contrast to folks who are sexually or romantically attracted to more than one gender or sex, like bi or pan identities. So we still are using that same binary thinking even if we're not trying to. There's some strong worries that the spectrum model is still reinforcing binary categories. Moreover, the spectrum model assumes that each dimension of identity can be reduced to a point on a continuum, but for a lot of people it's much more complicated. Identity can be complex and multifaceted, and looking at where someone is placed along a continuum doesn't always capture all that complexity. If someone has, say, highly masculine characteristics and highly feminine characteristics, the spectrum model would add those together and place them more or less in the middle of the gender continuum, in the same place as someone who has minimal, yet still supposedly balanced, gendered characteristics, and in the same place as someone who is agender. Placing 3 people with such different identities all at the same place on the continuum seems odd and reductive. The spectrum model doesn't give a framework for recognizing differences between someone with very strong gendered characteristics and someone for whom gender is not a component of their identity, so long as the sum total of their characteristics comes out about the same. It erases the important differences between these identities, as well as erasing the complexity within each individual's identity. Notice that this model doesn't have a way to identify which gendered traits a person has, or which gendered characteristics are a particularly strong component of their identity. We lose a lot when we try to reduce all the complicated complexities of something like sex, gender, or sexual orientation down to just a point on a line. Rather than putting people into one box or another, or even putting people somewhere along a spectrum, we have configuration theory. This theory views dimensions of identity as involving multiple, often disparate characteristics, which all matter, and which cannot be reduced to a single category or axes. This theory views people's identities as massively multidimensional and complex. Sari Van Anders, who created this theory, uses complex modeling to illustrate how configuration theory conceives of the many factors that go into a person's identity. These models are multidimensional, incredibly complex, and illustrate the vast assortment of different intensities and ranges of characteristics or preferences a person might have. Most people aren't trained in understanding multidimensional and linked data modeling, though, so we're not going to focus too much on these images. A simpler analogy can help us picture how configuration theory works. We can think of dimensions of identity, such as sex, gender, sexuality, as being composed of many different points, like stars in the sky. Each person's sky is unique. People's stars might be placed in different locations, and those stars can vary in intensity and weather and how they affect other stars, whether they pull on other stars or exist more independently of each other. There aren't idealized versus other kinds of skies, just different configurations. We can only really understand what a person's sky is like by recognizing all the complexity of the different stars in it. The stars can move and change over the course of someone's life. Sometimes those changes are minor, and sometimes they might change the shape of the whole sky. It's difficult to capture all the complexity of a sky, though. So in different contexts or for different purposes, say, if you're at the doctor versus when you're celebrating at Pride versus when you're relaxing with family, we might focus on just a few of the stars, or on the connections between specific stars and the picture those connections make, the constellation made by the stars we're focusing on. If we're using configuration theory to talk about dimensions of biology, we might focus on particular biological characteristics, without implying that someone who has one characteristic necessarily has other characteristics that have been associated with it in binary theory, or that the presence of that one characteristic signals anything else about the person's identity. An example would be talking about people with uteruses, or even more specifically, people who gestate, without implying that everyone who gestates necessarily has a vagina or that everyone who gestates is a woman. Whereas binary theory would hold that there are two and only two sex categories, and spectrum theory would recognize that there are several sex categories spread across a continuum. Configuration theory moves away from the use of categories and instead makes space for a great deal of complexity and variety, while still allowing us to focus in on particular characteristics or features as needed. There are lots of reasons why it can be important to be able to identify or refer to the group of people who have a particular characteristic, and configuration theory allows for that. But that's just a shorthand. Going back to our sky analogy, focusing on some points in the sky for a moment doesn't mean that the other stars don't exist or don't matter. At other moments, we might focus on other sets of stars and find different connections that are relevant or meaningful. All the stars are real, and they're all important. So we have three theories: binary theory, spectrum theory, and configuration theory. What do you think is gained or lost by each one? Which do you think best captures your identity?